For more information related to the civil engineering concepts and civil engineering updates, please visit my website civilbasics123.com. Go to type civilbasics123.com in Google so that my website will be open here like this. So which is consisting of all detailed concepts related to the civil engineering topics. So please follow my website civilbasics123.com. In this video lecture, I will explain you designing of earthquake resistant structure by using bracing system. Okay, so this is the first module in our series of earthquake resistant structural design concepts. Okay, in my previous video, I was explained detailed concepts related to the earthquake resistant building design methods and different types of the method that we are used as per the IS 1893 codal provisions. Okay, so these are the specifications. So I was already explained in my previous video. Okay, so please watch that complete video for the complete details. So in this video I will explain you the complete concepts related to the bracing system earthquake resistant building designing method by using ETABS software. Okay, so for that firstly I am selecting my ETABS software. So here I am selecting ETABS 18 version software. The complete software will be loaded here like this. So click on the file option, new model option. So in this we need to select the new model for the respected assignment. So why? Because I was not done the modeling process for the building structure. That's why I am selecting as new model. Okay, select the user building settings as per the metric SI system Indian standard provisions. Steel design code is IS 800 and RCC design code is IS 456. Click on OK option. Okay. So after that we have to enter the number of lines in X direction as well as the number of lines in Y direction, spacing between the X direction and spacing between the Y direction condition system for the building. Okay. So as per my example, just I am taking number of grid lines in X direction will be consisting of 7 numbers and Y direction will be consisting of 5 numbers and each grid will be consisting of 3 meter, 3 meter. So here we are taking the G plus 10 story building structural model. The total number of the floors will be consisting of 11 plus 1 plinth level, which is approximately equal to 12 numbers here. Okay, so here I am selecting typical story height is 3 meter and bottom story height is also 3 meter. So click on the grid only option, click on OK option. Okay, so that it will open the grid data as well as the 3D view for the respected building structure. Okay, so now we can see the left hand side window indicates your respected 2D diagram and the right hand side section window 2 indicates its 3D diagram for the respected grid lines here. Okay, so it will be consisting of A, B, C, D, E, F, G. Okay, 1, 2, 3, 4, 5 here like this. Okay, so initially we need to define the material properties. So as per the given problem statement, I was taking the grade of the concrete is M30 grade and grade of the steel is FE 500 grade steel. Okay, so for that click on the define option, material properties option, add new material. So here I am selecting my code as per the Indian standard system concrete section. So here I am taking the M30 grade concrete. Okay, again in the same process we have to take the FE 500 grade steel. So for that just I am selecting the rebar Indian standard system FE 500 grade steel. Click on OK option. Now we have to define the dimensions for the respected column section as well as the beam section. Okay, so here as per my example just I was taken the dimensions of the beam is 450 cross 650 and the dimensions of the column is 800 cross 500. Okay, so for that go to define option here, section properties, select the frame sections. Initially we need to delete all the selected parameters. So click on the delete property, multiple properties, select all the properties, click on delete option. Okay, so again I am selecting 2 more property, click on delete option. Now we have to add the beam size which is consisting of 450 cross 650. Okay, so for that we need to define the new property. So click on add new property option, select the rectangular property. So as per my example just I am taking beam size which is consisting of approximately 0.45 cross approximately 0.65. Okay, so material type will be consisting of M30 grade concrete provisions and the depth will be consisting of approximately 650 and width will be consisting of approximately 450 value here. Okay, select the reinforcement value and change the property from the column to the beam. Okay, so here I am selecting the HYSD bars of 500. Okay, and this top and bottom cover will be consisting of 60 mm. Click on OK, click on OK option. Now I am selecting ISLB 600, click on delete property so that it will delete the default ISLB 600. So now we have to click on the add new property option, the rectangular provisions. So as per the column dimensions it was obtained as 800 and 500. Okay, so here I am taking the column which is related to the 0.8 cross 0.5. Okay, Select the material is M30 grade concrete provisions and depth will be approximately equal to 800 value and depth will be approximately equal to 500 value. Click on the reinforcement to be checked. Select the column section which is related to the longitudinal bar and confinement bar of 500. Okay, so as per my example, just I am taking the number of the bars in 3 direction is 3 and 2 direction is 5. Okay, click on OK option so that it will develop the number of the bars here like this. So click on the OK option so that it will define the column sections here like this. Okay, so after defining the column sections as well as the beams dimensions, we need to define a slab thickness. So as per the problem definition, it was assumed as 230 mm, but for this respected G plus 10 story building model, 150 mm dimensions of the slab thickness is sufficient. Okay, so go to define option, select the section property, select the slab section property, add new property. This time selecting the property is slab is 150 mm. Okay, so again I am selecting the material is M30 grade concrete provision and this respected value is 150. Click on OK option and we have to select this respected slab one. Click on delete property, click on S option. Again select to plank one, click on delete property, click on S option. Okay, so that it will define the slab section which is consisting of 150 mm. Okay, so after defining all the properties, we need to assign those properties for the building structure. So here we have to select the property name is beam section. So select the create beams option, quick draw beams option. So in this we need to select the beam sections, just drag to the respected plan way so that it will assign the all the beam sections for the structure. Again in the same process we have to select the column section. So now I am selecting the column which is having the dimensions here like this. So here I am selecting the column section property for the building structure. Okay, so now I am selecting this respective property here like this. Now we have to assign the slab section, just I am selecting the slab section. So here I am selecting the slab section is 150 mm. Again we have to drag to the respected model 2D view here. Okay, so that it will assign the slab section here like this. Now we have to delete the slab section at the ground. Okay, again we have to delete the slab section at the plinth level also. So for that we have to select the base level, click on apply, click on OK option, select the one story option here, select the respective slab section at the ground story, click on apply. So click on delete option so that it will delete the property at the ground story. Okay, again in the same process we have to select the remaining slab section at the plinth level. Just I am selecting the slab property at the plinth level here like this. Okay, so in the same process we have to delete the all the properties of the slab section at the plinth level. Okay, so why? Because there is no slab section will be exist for the building structure for the plinth level. Okay, so after deleting the slab section at the plinth level, we have to define the load cases. So as per the codal provision, we have to define that respective property. So here I am selecting define option, select the load cases. Okay, select the load patterns option. So as per the default case, it will be consisting of two types of the load cases. One is related to the dead loading condition system and second one is related to the live loading condition system. Now we have to define the earthquake load in X direction condition system. Okay, select the codal provision is seismic as per the IS 1893 codal provision 2016. Click on add. Again I am selecting Y direction condition system. So here I am selecting earthquake Y direction condition. Click on add option. Okay, now we have to add the wind load in X direction. Select the wind parameter here and we have to select the as per the IS codal provision 875. Okay, so again I am selecting this respective property is Y direction condition. Click on add option. Okay, so as per the definition we need to enter the all these respected values. Okay, but for simple understanding just I am skipping this respected value. As per my assumption just I will take the random values. Okay, so here I am selecting IS codal provision 1893 codal provision. Click on modify option. So firstly we have to select the direction is X direction condition which is related to the per code value of 0.36 for the respected section. Click on OK option. Again in the same process just I am selecting the Y direction condition. So here I am deselecting all these properties. Just I am selecting this respected section is 0.36. Again click on OK. Now I am selecting the wind load. Click on modify option. Select the wind type will be of 55 and terrain category will be comes under the 3. Okay, so now we have to enter the wind direction angle. Just I am selecting modify option 0 and this respected value will be of 180. Okay, so just I am selecting here as 180. Click on OK option. Again click on OK option. Now I am selecting wind Y direction. Click on modify option. Select this as 55 and terrain category will be of 3 and this is 0.86. Modify this respective property and select the angle is 90 degrees and 270 degrees. Click on OK option. Click on OK option. So click on OK. Now we have to apply the respected load condition system which is related to the gravitational loading systems only. Okay, so before that we need to assign the bracing system for the building structure. So that is important in the earthquake resistant designing. Okay, so for that firstly we have to select the define option, select the section property, frame sections option. Okay, so here in this we need to import the property which is related to the steel section. So for that just I am selecting the import option. Okay, select the steel section option. Okay, so initially it will ask you to select the codal provision. Just I am selecting as per the Indian standard system and as per the concrete grade. Okay, material type. So we need to add the material type as per the concrete Fe 250 grade. Okay, so here I am selecting add material which is related to the steel section which is of 250 section. Click on OK option. Okay, so again we have to click on OK option, again click on OK option. So now we have to change that respected property to Fe 250 grade. Okay, so select this respected steel wide flange section. So it will add your respected property here like this. Okay, so you can select any one of the property from this respected value. Just I am selecting as per my example ISMB 300 value. Click on OK option so that it will add the property here like this. Click on OK option. So now we have to assign the property of steel bracing system for the building structure. So I was already explained different types of the bracing systems and their uses in my website civilbasics123.com for the complete details regarding the bracing system. Okay, so initially I will apply the bracing system for the building structure in alternative positions. Okay, so for that firstly I am selecting the one level here. So select the elevation level which is related to the one option. Click on apply option, click on OK option so that it will open the one level here like this. Okay, select the X type bracing system. Okay, click on bracings option, select the property name is ISMB 300. Okay, so here we have to assign the bracing system in X direction. Okay, depends upon your respected usage you can select the bracing system. So as per my consideration just I am taking the bracings which is consisting of the building structure as exist in X direction condition system. Okay, again in the same process we have to select the elevation section which is related to the approximately of 5 number here. Okay, click on apply option, click on OK option. Okay, so that it will open the property here like this. Okay, so now we have to apply the bracing system for this respected section. Just I am selecting this property. Okay, again I am selecting this respected property. Okay, so that it will apply the bracing system for the respected elevation of A. Again I am selecting the elevation section which is related to the G level. Click on apply option, click on OK option. Okay, so for that just I am selecting this respected property. Again I am selecting this respected property here. Okay, so now we can see it was assigned with all alternative position bracing system on the ground floor. Okay, so in order to model this respected whole bracing systems to the remaining stories we need to select the bracing system initially. Go to select option, properties, select the frame section, select the ISMB 300. Click on select option so that it will select all the bracing systems. Go to edit option here, select the replicate option. Okay, so in this we need to select the story number here. Okay, so as per my consideration just I am selecting this respected stories here. Okay, click on apply option so that it will apply the bracing system for the respected building model here like this. Okay, so now we can see it was applied with all alternative bracing systems here like this. Okay, so now we have to apply the load cases for the building structure. So for that just I am selecting the 12th story, click on OK option. So go to select all the building structure. Okay, so I was already explained how to calculate the dead loading condition system for the building structure in my previous videos. So you can watch that video. I will provide you that respected video link in below description and above cart link. You can watch that video from the complete details. Okay, so initially I will apply the self-weight condition system. For that select all the building, go to assignment option, joint point load, forces option, click on add to existing loading condition system. Just I am selecting here as 11111 as the self-weight condition system. Click on apply option so that it will apply the self-weight condition system for the building. Okay, so after applying all the seismic condition self-weight condition system we need to apply the wall load condition system which is the combination of the external wall load, internal wall load as well as the parapet wall loading condition system. Okay, so I was already calculated the wall load condition system which is consisting of the approximately the intensity is 24.3 kilonewton per meter. Okay, we need to assign that respected wall load condition system for the beams. Okay, so go to select option here, select option, property here, frame sections here, select the beam section, select option, close option, go to assign option here, frame line load, distributed condition system. At existing loading condition we need to apply the value is 24.3 kilonewton per meter. Click on apply option so that it will apply the 24.3 kilonewton per meter, which is the combination of the external wall load, internal wall load and parapet wall load condition system. Click on OK option. So now we have to apply the slab load condition, floor load condition system. So for that, go to select option, properties, slab section, select S150, click on select option, close option. Go to assign option, shell area load, uniform condition system, add to existing condition system, which is consisting of 2 kilonewton per meter square. Click on apply option so that it will apply the dead loading condition, floor load condition, which is of 2 kilonewton per meter square. So again, in the same process, we have to apply the live load condition system. As per the residential building, it will be consisting of 3 kilonewton per meter square intensity. So for that, we have to select the previous section PS. Okay, go to assignment option, select the shell area load, select the uniform load. Again, we have to change the load condition system to the live loading condition with intensity of 3 kilonewton per meter square. Okay, click on apply option, click on OK option so that it will apply the respective loading condition system as per the consideration. So now we have to apply the load combination system. Okay, go to define option here. So again, we have to select the load combinations here. Okay, select the default design combinations as per the concrete frame design. Click on OK so that it will develop the load combination systems here like this. Click on OK option. So again, we have to apply the support condition system for the building structure. Go to select the plan view, click on base system, click on apply option, click on OK option. Select the one story option, select all the node points at the base. Click on assign option, joint point loads, restraints option. Select the fixed support condition, click on apply option, click on OK option here. Okay, so now it will apply the support condition system for the building structure. Now we have to analyze the structure. So before that, we need to assign the diaphragm for the building. Go to assign option, joint point, diaphragms. Select the D1 option, click on apply option so that it will apply the diaphragm for the building structure under consideration for the whole structure. Okay, so now we have to analyze the structure. Go to analyze option, check models option. Initially, we need to check the joint checks so that it will show you the warning message here like this. Model has been checked with no warning message. Click on OK. Again, go to analyze option, set load cases to run option. Click on run now option directly. Okay, so initially it will ask you to save the model. Just I'm selecting the earthquake resistant model ER folder, in which it will be consisting of bracings models. Okay, so click on save option so that it will do the analysis process for the respective structure. Then after that, I will show you the values which is related to the deflection diagram, shear force diagram, bending moment diagram for the building structure under considerations of the seismic loading condition, and I will show you the tabular format values which is related to the time period, frequency, displacement value as well as the story drift value for the building structure. Okay, so it will take some time for analysis of the building structure, which is of G+10 with the bracing system. Okay, analysis process under considerations of the various types of the load cases and load combinations by using ETABS software. Okay, then after that, it will display the displacement diagram for the building structure under considerations of the specified load case. Okay, so now we can see it was done with analysis process. This is the deflection diagram. It will be consisting of different types of the values of the displacement at each and individual points. Okay, so in order to display the displacement diagram which is related to the seismic loading condition, we need to go to display option, deform shape as per the seismic x direction condition. Click on apply so that it will display the diagram here like this on the left hand side. Okay, so again we have to click on the close option here. Okay, now we have to see that shear force diagram, bend moment diagram for the building structure. Go to display option for that, select the forces, select the spear spandrella force, select shear 2 option, click on apply so that it will display the shear force diagram. Again click on moment 3, click on apply so that it will display the bending moment diagram. Select the torsion option, click on apply so that it will display the torsion for the respected building under considerations of the load cases. Okay, so after developing these respected diagrams, we need to see the results as a tabular format. Okay, so for that, go to display option here, click on show tables option. Okay, so select this respected load cases as per your consideration. Just I am taking only the seismic loading condition systems. Okay, deselect the load combinations also. So you can select the joint displacement value as story drift value, and reactions you can select. Otherwise you can select directly as element output values which is related to the structural one. Okay, base reactions you can select here, and time period frequency values you can select here, and values of your respective shear forces, story forces. Okay, click on OK option so that it will load the values which is related to the base reactions here like this under the conditions of the earthquake loading condition system, and model time period frequency values here like this. Again, this is a story drift value and this is a story forces value. Okay, so in my upcoming video I will explain you comparison between the results which is related to the general building model as well as this respected bracing system model by using ETABS software. So if you have any queries about this respected video, please try to text me your questions in the below comment box. I will try to give the answer for the respected questions. Thank you.